Hello everyone, I'm here to present our project, Duel Master, a Yu-Gi-Oh card translation system. We are Group 20. This is our outline. First, I'll talk about motivation and objective. Yu-Gi-Oh, a trending card game, holds on a special space in many college student childhood memories and continues to captivate players of all ages today. However, the modern Yu-Gi-Oh! Rule set has evolved far beyond its original straightforward number-based battles. A single card now contains extensive Japanese text, and the gameplay is governed by an intricate web of rules and regulations. Many players who step away from Yu-Gi-Oh! To focus on academic now find themselves in an interesting position. Looking back at the game feels like encountering a familiar stranger. The complexity of the current state of Yu-Gi-Oh! Can be intimidating, making it challenging to return to the game they once loved. Based on the above pain points, this challenge inspired us to develop an AI-powered card translation bot equipped with a straightforward Q&A system. Whenever you are a complete beginner or a returning player hoping to re-enter the world of Yu-Gi-Oh! Our model can help you get started and provide instant translation of the latest card effect. Next, I will discuss our reality world and market survey. Currently, there are several Yu-Gi-Oh! Knowledge tools available online, such as Customized GPT and base translation software developed by Taiwanese developers. However, these existing solutions have certain limitations that we aim to address with our project. Let me show you. Looking at this comparison table, there are three main solutions in the market. First, we have constant GPT models, which are primarily valued for their easy integration with ChatGPT. However, these models are limited by their predomination English language support. The second category is translation tools, which offer instant translation capabilities. However, these tools is specifically designed for online games. Now, we set our solution apart. We have developed a system that combines image recognition technology with an interactive Q&A system. But what I'm particularly excited to highlight is our user interface. Let me walk you through our AWS cloud architecture. We built our infrastructure within a VPC spanning two availability zones. When users access our website, their requests are fed direct to the web server located in the public subnet. This web server then forwards API requests to our backend through the application load balance. Our system's core components include 1. Internet gateway. 2. Public subnet. 3. Private subnet. 4. Application load balancer for traffic distribution. 5. Auto-scaling group of dynamic resources management. 6. Amazon EFS for shared file storage. For image processing, when users upload CAP image, they are stored in our Amazon EFS, allowing access from EC2 instance across both Availability zones. The backend processes this image for text recognition and translation. And this is our project outcomes. We have successfully deployed a Yu-Gi-Oh card translation system. It features a user-friendly web interface that has received particularly positive user feedback. In terms of functionality, we have implemented image-to-text translation capabilities, include image recognition, text extraction, and real-time translation precision. Let me present our system overall architecture through this mind map, highlighting this significant change from our midterm proposal to the final version. In terms of data storage, we made a major adjustment initially in our midterm proposal. We plan to use RDS for storing translation and Q&A records. However, during implementation, we found that EFS was a better choice for our AI model storage and access requirements. This change allows us to more effectively manage and share AI model files. For security and traffic management, we optimize our architecture. We replace the original AWS WAF protection with an Internet gateway and the NAT architecture, providing better control and management of network traffic while maintaining system security. The backend architecture also saw significant improvement. We separate the original single backend service layer into web server and application layers, deployed in public and private subnets, respectively, greatly enhancing system security and maintainability. Now, I'd like to highlight the most time-consuming part for our deployment processes. First, in front-end development, we encountered two main challenges. First, the first issue was with Canvas rendering card image showed different size between mobile and PC display due to the pixel ratio difference. And we resolved this by implementing fixed aspect ratio with dynamic scaling. The second challenge was ongoing code refactoring and quality assurance. Well, this didn't affect the final output, but it was crucial for maintaining low coupling and ensuring code quality. This continuous improvement process made our code base more maintainable and scalable. And in NWS deployment, our main challenge was establishing proper communication between various AWS services. We spent considerable time ensuring all components could interact correctly with each other. For team interaction, we maintained effective communication through two main channels, Google Meet and Line. This is our reference. Then let's we demo.
Okay, I will show the actual setup of the AWS architecture, followed by a demonstration of the website's UI. Since the Learner Lab doesn't support GPU instance, so the image-based translation feature will be presented by the later video. So let's start with the architecture. So you can see that first, you can see that there are two backend instance and one front-end instance currently running. And the front-end instance is in the public subnet. Here, public subnet. Here you can see that public subnet, and the front backend instance is running as the private subnet. So and the backend instance are managed by an auto-scaling group, which adjusts the number of instances automatically based on demand. The load here. The auto-scaling group will use CloudWatch to monitor the CPU utilization and adjust the numbers. So here is the 2, and when its maximum number is 6. And the load balancing is handled by the ALB load balancer, and which directs traffic to the backend group where our backend instances are located. And you can see that here is the backend load balancer, and it will direct traffic to our backend group, and this backend group is our backend instance. You can see that here is our 2 backend instance, and it will monitor its healthy status. It will check its status and direct the traffic to the instance. So this is our AWS architecture look like, and next we will take a look at our website. So we use the IP address, so you use our IP address to our website, and you will see the start button and the UI interface, and we click the start. And click the start, we will enter the chat room, and in this chat room you can send message like this, and the robot will reply you. And also you can upload the images. We upload our AWS architecture. Yeah, it will reply you. And besides, we can rename our chat name. We name first chat, and you can see that first chat. Also, you can add the chat room, chat 2, chat 3, chat 4. In this chat, you can also do something. Yeah. Room 3. You can see that the name is changed. And also you can delete the chat if you don't want. Yeah, this is our website UI. So let's a quick overview of the AWS layout and the website. And the translation main features will be demonstrated separately. Thank you.